Hey everyone, I want to thank you for tuning in to one of Epartrade's Race Industry Now Tech webinars. If you're a part of the racing industry or you're just passionate about racing tech, don't forget to like this video and subscribe to our channel so you never miss a new episode.
Morning and welcome to Race Industry Now, the weekly webinar series from Epartrade, presented to you by ARP, Performance Plus Global Logistics, Feria, Peak, Fifth Third Bank Motorsport, Quarer, and CTEC Manufacturing. I am Francisque Savignan, the founder and CEO of Epartrade, the racing industry, every minute, every day. This is episode 545, and we're going to be talking with Halo P1. With me this morning are Judy Kin, the co-founder of Epartrade, and a wonderful host, Mr. Brad Gillie. Judy?
Thank you, Francis. Thank you, everyone, for joining today. We are delighted to have Halo back on this technical webinar series. You know, they are just one of those companies that is innovative and dynamic and really have made a huge footprint within our industry. Delighted to have them back on. Brad?
Yeah, I am as well. We had a great time the last time we were on here and learned a lot about the amazing products that they make. So I really look forward to today's presentation. And Judy, Francis, we'll talk to y'all here shortly and really look forward to learning about what we have coming up here today. Our topic today, the title, The Science of Braking, KPIs and Data That Win Races by Halo P1 Brake Fluid. And our panelists today, we have Lloyd Ker, the CEO, Dan Stafford, Chief Development Chemist, and Sergio Bonfanti, Motorsport Industry Expert. So as we're getting everyone on, let's welcome Halo P1 and look forward to a big one. Lloyd, we see you here. Let's go ahead and get started. Tell us a little bit about what we're going to be talking today. I know you have a great presentation lined up.
Yeah, well, still the guy's thunder, Brad, but really good to see you again. It's been a little while since we last were on. How long ago was it? About a year ago?
It doesn't feel like that long, but you're probably right about that.
Yeah. So yeah, today will be Dan Stafford, our Chief Chemist, Chief Development Chemist, and Sergio Bonfanti, who's been working with us from a brake engineering perspective, from a technical engineering perspective. And the whole thing will be around, proving the performance advantage of Halo P1 through data rather than through perception.
Yeah, I like that, especially when we're, talking about real data and we're talking about real numbers. Sergio, welcome. Tell us a little bit about yourself, if you don't mind.
Good morning, good afternoon, good evening to everyone. Involved in the racing industry since 34 years. As you can see from my face, I'm not that young anymore, unfortunately, but still enjoying. So I'm delighted to be here with you today, and I will try to make, in as much as possible simple words, the explanation about the data and the KPIs we are going through when introducing the product to a new team.
Awesome. And Dan Stafford, welcome here. We look forward to picking your brain with a lot of great knowledge. And again, I love it when we start talking about things that really involve true data and what you really see in the numbers. How you doing?
Yeah, I'm very well, thank you. Good morning, everyone. Yeah, so I'm Dan Stafford. I'm the Chief Chemist of Halo Biothene. So I get involved with all the chemistry side of the products and in the development and things like that.
That's wonderful. Before we get started with the presentation, I do want to start with this. And when we talk about the products that we're featuring here today and talking about the technology and all the data, where is Halo P1 available? Is it just in Europe or is it in other regions as well?
It is in other regions as well, even in the US. Sorry, Lloyd, over to you, please.
And all good. Yeah, so it's in all of the main territories, Brad.
Yeah, I just want for our audience here, I just want to make sure that everyone knows this is something that they have access to. This is something that they can get, and this is something that will be a huge benefit because look, we talk about all the things that make us go fast, and I think as every racer knows, going fast also involves being able to slow down very efficiently and consistently throughout the course of a racing event. So I know we have a PowerPoint presentation. Is that something you want to get started, Lloyd, Dan?
Right, if you crack on to the next slide, and for just for the benefit of some in the audience who wouldn't be familiar with Orthene, obviously Halo's our own project, our own brand, but I'll go through a bit of a backstory on Orthene, and then Dan and Sergio will go through the fun stuff and the technical stuff, and then we'll finish off with a Q&A. So launching into the introduction, just to give the audience a very high level overview as to to Orthene. If you just flick onto the next slide. And again. So we've got a fairly extensive background in brake fluids. We are the world's largest specialist producer of brake fluids. That's all we do, just one core focus. And traditionally for, well, the last 50 years, it's our 50th year next year. It has been 100% private label model. So you can think of any of the main big brands out there, mainly in the aftermarket automotive space, and also in the performance space. If they've got a brake fluid, it's likely that would come from our factory. So that's been a very successful model, and we want to continue that for as many years as we possibly can. But what we realized, if you just flick onto the next slide, what we realized with a private label model is that to maintain that cutting edge technology and innovation, we had to get closer to the consumer. And one thing we're really passionate about is racing. My grandfather, even back in the 60s, before he started the business, was working with Sterling Moss and some other racing drivers to generate the next generation of brake fluids. And we've continued that year on year for the last 50 years. And now we want to take the bar even higher. But to do that, we had to get closer to the consumer. And we spent from about early 2022, we actually called it the Halo Project. Spent nearly 2 years talking to race engineers, technical directors, team principals, drivers, sucking up, learning, absorbing every single bit of information as to what actually happens in the brake system at the racetrack. And we compiled all that data and all that learning into what is now the Halo P1, which we launched in January 2024. And we're now sort of 18 months in, and it's just been an amazing journey, Brad. Such a privilege to work with such high profile teams, obviously some of which we can mention, some of which we can't. But to be represented in just about every major pro race series now globally is just so fun, so amazing. And it's really started to drive that innovation cog for the next generation of fluids. So again, I won't steal the guys' thunder, and they'll go on to the fun bits and the technical side, but it's been an amazing journey so far. We've had some great highlights. Just came off the back of Le Mans 24, and we've had an Indy 500 win with Chip Ganassi. That's one of our technical partners. So just these golden nuggets. We're so early in this story, or so early in this journey, but there's been some significant wins, and we're only just getting started. So super fun, really excited, and I'll hand over to Dan.
Okay, next slide, please. So thanks, Lloyd. If you tuned into our last year's presentation, it went into great detail about brake fluids in general, how we make them, what they consist of, and things like that. But in this one, I'm just going to really talk about racing brake fluids, because they're actually quite different to brake fluids you would put in your car and drive on the street. So a road brake fluid is a blend. So it's a blend of a number of chemicals. The main groups of these are glycols, glycoethers, boric esters, and additive packs. And they're all blended together. The glycols are primarily there to give you a lubricant function. Glycoethers are basically the main body of the fluid, and the boric esters is what gives you your performance. And we blend all those together to give the different characteristics you need for a road fluid. As Lloyd says, we make about 20 million liters of that a year, so we're pretty good at it. But it's a blend. With racing fluids, it's completely different. Racing fluids are not a blend; they are a single custom design molecule, which we make and design ourselves. They are an ester. All the racing brake fluids on the market are custom design molecules. They're pure molecules, and we add some additives to them as well to give the performance advantages and different characteristics we need for the different racing products. But the design premise is fundamentally different. Obviously, the road fluid, you need a longevity. They typically stay in a car for 2 to 3 years. Needs to protect the components from things like corrosion and galvanitic attack, because you've got lots of different metals in the brake system. We need to make it from commercially available ingredients, because as we say, we make 20 million liters. So we need to be able to get hold of those ingredients in big volume. It's obviously cost competitive. We have a lot of competitors in the market, and we need to make it in high volume. With a race fluid, it's completely different. We're focusing on ultimate performance only. And the difference is the product has to be durable during its use, and durability is different to longevity. So durability is about keeping that ultimate performance during its use. So we don't want the performance of the brake fluid to drop in any way. And because that will affect the operability of the brake system in the race car. One of the fundamental precepts as well of a racing brake fluid is fluid dynamics, and I'll go on to that in more detail in a minute. But it's basically the science of how the fluid behaves in the car during race conditions. And as I said, we synthesize these ingredients. We actually design the molecules here at Orthene in London, in England. And another important thing, we don't want any impurities in the product. So we spend a lot of time purifying the product before it goes into a bottle. So what are the metrics when we design a racing brake fluid molecule? There are many, but there are three main ones. So if we go on to the next slide. As I just mentioned, it's fluid dynamics, very, very important. We spend a lot of time looking at the fluid dynamics of the fluid. Obviously, we want the brake fluid to be as incompressible as possible, so we get efficient force transfer. When you apply pressure on the master cylinder, we want that force to be transmitted down to the calipers. If there was any compressibility, you would lose efficiency, and you lose that connection, the feel of the brake fluid, of the brake pedal, if you like, if any of that force was absorbed. So we spend a lot of time designing the molecule to make it incompressible. And also, the process of braking is all about pressurizing the system and then releasing that pressure, and the pressurization or the braking event is very important, but also when it's depressurized, when you're coming off the brake pedal, that is also very important. So we need a linear response. So we want the fluid to behave in a linear way when those pressure events happen. And ultimately, this basically gives a very good consistency in brake modulation and the control and feel of the brake pedal, which translates to the driver as a very consistent sort of braking feel as he goes around the track. And we attain this by our custom molecule design. We spend a lot of time putting ingredients together, reacting them together in the lab, and then testing them chemically and also in test rigs to see how they behave under racing conditions. So next slide, please. And obviously another very important aspect of a racing brake fluid, especially these days, is friction, especially friction and how the system behaves under load or stress. Obviously, a racing environment is very stressful on the components, so we need to maintain very good lubricity. So a typical race brake fluid has a very high lubricity factor at high temperature, because obviously it's spending most of its time at high temperature. And this is really to assist smooth linear operation of the system. We don't want any hang-ups or when you're releasing or applying the brake pedal. We want it to transition very smoothly, and high lubricity assists this a great deal. And especially in a brake system, obviously, it's all about how the elastomer or your seals behave against the metal surfaces. So we are especially, paying attention to how the brake fluid lubricates the elastomer surfaces to make sure that we get good release. And all of this assists with a smooth and quick transition, because that's really what you want. You want the brakes to go on quickly, provide your friction event so it slows the car, and then you want the brakes to come off very quickly and release quickly, so you can get back on the power. And obviously these days with racing cars, you've got ABS systems entering into closed wheel racing. So obviously, depending on the skill of the driver, a less skilled driver will use the ABS quite a lot. And the ABS pump needs to be protected, and these run at very high frequencies these days. And obviously, a good lubricity helps with caliper rollback, keeping the transition as the friction materials come off the disc, keeping that nice and linear and consistent. Next slide, please. The third thing everyone talks about with the racing brake fluid is high boiling point, and our boiling point is higher than everyone else's, so it must be the best brake fluid in the world. It's technically true. A good boiling point is important for a brake fluid, but it's not really the number. Even those ours as the highest boiling point on the market, it's about a high boiling point gives you consistency in the brake fluid and the system. So a good temperature resistance or high boiling point gives you consistent performance over the things I've just talked about in the temperature envelope that the brake fluid is operating at. So, if the brake system is very hot, we need to maintain that good incompressibility, the good fluid dynamics, and the good lubricity of the system. And as the brake fluid heats up, you tend to see a drop off on these things. So a well-designed brake fluid will maintain these properties at very high temperatures. And this is basically what makes a good racing brake fluid. Next slide, please. So, we talked about the Halo P1. We've spent the best part of 2 years designing it before it's launched. It's a very unique chemical. And it has all of these attributes. So it has a very high boiling point to start with, and very, very high lubricity. We actually react some chemicals into the backbone of the product, which is unique to us, which maintains a very high lubricity at high temperatures. And we spend a lot of time looking at the molecule design to make sure we get the ultimate fluid dynamics. So I know I'm going to hand you over to Sergio, who will talk in an engineering language about the product and some of the wins we've had this year.
Thank you, Dan. If we can go to the next slide, please. We'll try to understand how, let me say, to translate with objective data all the good work that Dan and his team, so the chemists, are putting in order to improve the product. And now that we are, let me say, starting to be heavily involved in motorsport, you can be sure that Dan and his team are spending a lot of hours because it's all about continuous improvement. So the P1 is the starting point, and then you will understand later on which one is the broader vision. But basically, when we are out there, we are having to deal with the very simple formula that we are seeing on the screen, which is kinetic energy. What it is about, it's the amount of energy which is generated by the vehicle, which has a certain mass and goes at a certain speed. Obviously, of the two variables, the most important one is the speed of the vehicle. And basically, all this energy has to be transformed into heat through the mass of the braking system, and especially the brake pads and the discs. But then the heat is going back into the caliper, and we can see in certain environments that the caliper are reaching even 280, 300 degrees. It's not ideal, but we're having to cope with those things. And obviously, all that heat is going back into the brake fluid. And that is why it is so important, as Dan was stating, to have the heat resistance as a top characteristics as well to be taken into account when developing the product. But there are objective ways that are, let me say, making life easier to every engineers when having to take quick decisions during a race event or during a test event, when they have to maximize all the amount of money that they are spending to be out there. So if we go to the next slide, we are starting to see a few KPIs that at a glance are giving us useful information to understand if a product is better than another, if the product is still behaving in the same way as when it was new or as the last time, because that is something that we need to constantly check in order to maximize the performance of a racing vehicle. So if we can go to the next slide, please. All the KPIs you are going to be seeing are applicable to both type of braking systems using the ABS or not using it. But basically, depending on if it is used or not, you will see on data completely different things. As you can see in here, you have a classic pressure curve. The red one is the one with the ABS, the blue one is the one without the ABS. As you can see, the values are extremely different, and the shape of the curve as well is very different, because basically the ABS is doing everything when the driver has the privilege to have it on board. So basically there is the huge kick that you will see in the next slide, and because the ABS is then controlling the slip ratio, the locking of the wheels. Not having this privilege, the driver has to be much more careful in the way is putting the pressure in the system. And obviously the hydraulic package, so the master cylinder, is sized accordingly. If we can go to the next slide, please. You can see in here exactly the kick. On the x-axis, you have the pedal displacement. Obviously, we had the privilege to have a potentiometer installed on the car. As we are working, let me say, in the pro area of motorsport, many teams are using all kinds of sensors applied on brakes, and the potentiometer is able to measure the pedal displacement. In this case, in function on the y-axis, there is the pressure. So you can see on the very right, and it is divided, green it's the front axle, red is the rear axle. As you can see, you see the huge kick at the beginning of the braking on the right side of the graph. So it is reaching approximately 120 bars in this case, and then there is the release. Yeah. The most important part of the braking is the one right in the middle, because the driver is already releasing. The car is not anymore with a four-wheel straight. So basically the driver is starting to brake and turn at the same time. And that is the part of the braking which we call the combined braking, which is the most critical one, no matter if with ABS or without ABS. Yeah. And you can take out a lot of time if you do this properly and you get to the point of rope without posting too much, because at the end of the day, and we will see a slide dedicated to that, but basically during braking or during driving, there are usually three phases. The driver is pushing on the accelerator, which is the best part of it, because the lap time is coming out if you are pushing hard on the throttle. There is the braking time when you are pushing on the brake pedal, but there is some part during the lap where the driver is just doing the spectator. That time, it's when the driver is not braking or accelerating. That time is called coasting. Yeah. The less time the driver is staying on coasting, the quicker the car is going to be in the majority of the cases. Then, I mean, in endurance racing, there is the strategy, the calculation of the wear of the brakes and so on. So you might be willing to have some coasting, but the performance, let me say the pure performance lap, the qualifying lap, you need to have as less coasting as possible. If we can go to the next slide, please. And this slide is very useful as well to see if the rear and front axle of the brakes are connected. And that is seen basically by the angle that the two curves have. And if you see that one of the two is not reaching, let me say, the maximum temperature, you should start thinking that you might have a problem in the system. Usually, you can see the master cylinder problems. But again, when we are on a racetrack or on a testing day, time is very precious. So we need to have KPIs that at a glance are telling us if the product we are testing or if the product we have on the car is performing appropriately. In this case, it is a comparison test, and we were lucky enough. This is a real case, a race case. It's a WEC race, so not very old one. 1 month ago, 1.5 months ago in Imola. So it was an endurance race, 6 hours, and the snapshot you see right now, it's in the 6th hour. Obviously, as you see, 2 data, they are coming from 2 cars, but we were lucky enough that the 2 cars were having the same brand, the same setup, the same 2 pro drivers, so the same level, and they finished the race with 15 seconds of difference. One of the 2 went to podium. Yeah, so it was the perfect situation to see the progress during the race of the performance of the product. And in here you can see on the left side the deceleration on the X-axle and the pedal displacement on on the Y-axle. The one in the middle, it's more of the same. What I mean is that on the Y-axle, you still see the pedal displacement, but on the X-axle, you have the brake pressure. And you can appreciate how the green dots, the white line, it's, let me say, much less variable, so much more stable. And if you can see in the center one, there were at the end of the race 4 millimeters of difference in advantage of the white one in terms of pedal displacement, which means a much better feel. Yeah. And you will see how that is going to pay off. You can start appreciating it on the right side of the slide, because that is a GG graph where basically the bottom of the art is the deceleration, the upper part of the art is the acceleration of the car. And you can appreciate how green is dominant in the graph, which means that there is a much better acceleration, and the combined braking, especially if you see on the right side, because this was a left, there were more corners on the left, and therefore the loaded wheels are the ones on the right, and that is why you see on the bottom part of the art more dots on the right side. But basically, there is a much better longitudinal deceleration, being the lateral basically the same when the 4 wheels are when the car is on the straight. If we can go to the next one, please. So these graphs are basically taking from the same as the ones you saw before, and you can see that out of the corner, the speed on the green line left of the slide, it's always a couple, 2 or 3 kilometers higher than the red one. That is because the feeling is better. The driver is more precise and is able to release in a much better way. And those 2 or 3 kilometers are kept until the next braking area, which means that is paying off in lap time. And if you can see the pressure curve right on the bottom, which is generating that delta of speed decreasing, you can see that the green one is much lower and much more precise. Yeah, and that is again about feel. The higher speed might be a function as well of a quicker release, so of a rollback of the piston, which is basically stopping the friction between the pad and the disc in a quicker way. And you can see that in the right side of the graph, because you can see the traces of the front and rear discs temperatures, and you can see that the green line is always below the red one. Too small to read the data, but there are 30 to 40 degrees less in the disc, which is a privilege for an engineer, because you don't want your pressure of the tires to be upset by the heat which is coming from the brakes. And I mean, if you have space, you know that on a race car there are ducting systems that you can close, you can open in order to stay in the appropriate window of temperature where basically the ABS is not getting mad, or if without ABS you are able to express the right level of initial bite and the right level of retardation, which is allowing you to get to the point of rope in the best possible way. If we can go to the next one, please. So this was basically the feedback we were given by the engineer that was making the case that I just showed you. So I'm going to read it to you. During winter testing, LOP1 has a clear advantage in compressibility and lifing. The team is French, so lifing is less deterioration. Feedback was positive, and when drivers had no clue what product they were using, anonymous test. We faced no issue and all parts look clean, not more used than expected. Braking is one of the weaknesses of our car. These improvements help a lot, both on peak performance and long stints. We plan to run with halo fluid on both cars for Le Mans and the rest of the season, which is the best compliment that I believe we could have received. If we can go to the next slide, please. So in ABS, even when we have a car with ABS, there is another KPI which is nice to have if we don't have the potentiometer installed on the car. Basically, there is a channel on a Bosch M5 and 4, which is giving you the displacement of volume of fluid that you are having on the front part of the system and on the rear. So basically, if you are only having the variable of the fluid in the system, you can appreciate, let me say, the advantage that the fluid might give in terms of incompressibility, as Dan was rightly stating. If we can go to the next, please. And this was the topic I was already touching while presenting another slide. These are basically the three phases that you can appreciate. Usually you calculate the time during the lap, and basically you can calculate the time when the driver is on the throttle. You can calculate the time when there is pressure in the system, and therefore when you are on brakes, and you can calculate as well the time when basically the driver is not pushing on the accelerator or on the brakes, and that is the coasting time. It's really critical for us, being braking expert, to minimize the coasting time for the lap performance. And again, it is a KPI that at a glance we can always use to understand if by implementing a change on the braking package or on the setup or whatever, if we reach the goal to lower down the coasting time, because that is going to be a lot of help in qualifying. If we can go to the next, please. Any action we do on the race car, no matter if setup, brakes, whatever, it has an impact on vehicle dynamic. And this is the classic KPI that engineers are using, the Joe. So the attitude of the car to be oversteering or understeering, because any change you make on a subsystem on the car, it has an impact on the wider system, which is the race car. And basically, you want to see this graph, the thinner the better. Yeah? I hope I've been clear enough and exhaustive enough. So I think I'm ready to pass back the word to Lloyd for his finishing slide. Thank you.
Thank you, Sergio. Yeah, again, I hope that's been really helpful and very insightful. Thank you very much. So if you just pass on to the next slide. So I guess some of the questions we've had from race teams and from our customers is, what next? Is it one product strategy, or where are we going? And I think the beauty of being a chemical expert in the motorsport space is that we're getting direct feedback from these teams saying, look, if you can help us improve your brake systems, our brake systems this much, could you help us with this, or could you help us with that? And we've dabbled in a few things, and we're already supplying some weird and wonderful things, very, very, very specialist, to some of these high profile teams, because they see us as chemical experts. And I think previously we have probably been very brake fluid focused, but I think now we probably see ourselves as more chemical engineers, making fast cars faster through expert technology, expert chemistry. So it's broadened our outlook, and there's already some projects that are rolling for 2026. There's a few listed there, some very exciting projects which are well underway, and some more news will be coming to the Halo audience, or you say the Halo customer base, in due course. But some very exciting things.
That is exciting. Yeah, I look forward to the two-wheel fluids coming out in 2026 myself. But if anyone has a question, please feel free to type it into the chat. We'd love to answer anything that you want to talk about specifically as well. And you know, a lot of really amazing things, especially when it comes to the data and what you were talking about, less coasting time, or talking about literally a side-by-side comparison, and a 4 millimeter difference in the brake pedal between the Halo fluid and the non. Are you guys seeing more benefits in specific series or areas of racing than others? And if so, which ones?
They can all enjoy the advantages that the new product is bringing. No matter if with ABS, without ABS. At the moment, we are mainly moving, let me say, in the more professional part of the racing industry. But because we are still, and it's going to be continuous improvement. So you need to rely on vehicles, pro drivers, and very skilled engineers in order to move fast, because racing is about being fast.
Yeah, well, I think we all know that when it comes to professional series, we're not talking about seconds on the racetrack. We're talking about fractions of seconds, and
Absolutely.
and every little bit can make a difference. Which is a big thing. We did have a comment from Peter Weiss. He had to run into a meeting, but he says he talks with you constantly, Sergio, and the problems in his team. And he just wanted to say hello to everyone. And as soon as his situation allows, he's going to switch over to Halo Fluid. And obviously, if this is someone you're spending time with, he, knows the details of everything that you have going on.
Yeah, well, I know Peter quite well since 35 years. I think he was one of my first teachers about data acquisition. That means that Peter is much older than I am. And I saw him the last time, last weekend at Le Mans. So we are tuned. It's always great to be working with him, because there are two types of engineers. The dogmatic ones, which are usually listening to the customer, to keep him happy. And there are the real engineers ones, which are the ones that wants to know, that wants to find out, that they are curious, and they are triggered by data. So it's all about data for them, and those are the ones that are usually winning races.
Mm-hmm. All right. Here's a question from the chat. It says, can you give any insight into differences between a motorcycle focused and an automotive focused brake fluid? Separate question, are there any long-term concerns we should have when utilizing a racing brake fluid regarding system protection, much like using distilled water in race cars instead of coolant? So that's a two-part question. So I guess the difference between motorcycle and automobile, and then is there any worry about, longer term concerns in having brake fluid? I'm sure in a racing application, we're changing brake fluid much more often than we are in a street application. But how could you answer that?
You want to take that one down?
Yeah. So with a motorcycle, you've got a lot more intrinsic vibration in the motorcycle from the engine and things like that. And generally, the master cylinder reservoirs and supply pipe work are very close to the engine. So, I ride motorcycles. I'm not really interested in cars at all, but, it's the job. So if I'm into my BMW, so they put the rear master cylinder really close to the engine. Not a particular problem on those bikes because they're 4-cylinder, but some of the B twin bikes, you can get a lot of it's not bubbles or anything like that. It's called a constant air entrainment. So you basically get the fluid churning over. So with a motorcycle fluid, and it's something we're finding out about because a lot of people in the motorcycle industry went for a 5-1. for road bikes specifically. But the problem with the 5.1, it's really too thin, and it tends to break off the walls of the master cylinder, and you can get air entrainment. And this is a big problem on sort of V-twin bikes. Certainly the brands that put V-twins in motorcycles. So well, for road bikes, we're in the process of developing bespoke brake fluids, which change the surface tension of the brake fluid to stop that air entrainment happening. On racing bikes, they're again extreme machines. Products like P1 are very important, and they're making good penetration into the racing bike market. But with bikes, it's very emotive. We're bikers, you get very emotional about the thing. So the rider has a lot of preference about the lever feel. So, obviously Sergio would argue with me, and you say you could change that with master cylinder displacement, change the size of the master cylinder and all that. But you can have we've done a lot of testing in British Superbike with one of the major Japanese manufacturers. Same bike, because they're all homologated. They have to be exactly the same. But one rider loved P1 and the other rider didn't like P1 at all. But he liked another fluid that we put in there as well, because we tested two fluids on that day. And, there's no sort of a tangible scientific reason why that is the case. But, it's just the way people ride. Some people have different braking styles, so they like different setups, and it's good for us because we can get to design custom fluids.
Yeah, I love that. By the way, as a BMW rider myself, who's about to change the brake fluid on his Boxer Twin tomorrow, I'm right there with you. So,
yeah, brilliant.
Question came in from email. What makes the Halo P1 better than the highest grade brake fluid from Ferodo? It had FRF 340 and AP Racing. As I know, otherwise, Orthene is producing the brake fluid for Ferodo and AP Racing. That's the first question from this email.
Dan, if I kick that one off, obviously we're very have to be very sensitive as to some of the brands we produce for, and it's not something we're going to be sharing on this call in terms of how, what, why, when. But just talking through the process in which we make the Halo P1, Dan, do you want to talk us through about the polarity and the purity of which that fluid is compared to other fluids?
First thing, it was alluded to there. We do produce a lot of bracing brake fluids, but they're all different formulas because we work with a lot of OEMs, brake system manufacturers and suppliers and things like that, and they want, they come to us with a particular key attributes they want from their fluid, and we develop them. So the fluids aren't the same is the first thing. But with the P1, we started with a clean sheet. We tried to make, obviously it has a very high boiling point as other products do on the market, but we really looked at what the important aspects of a brake fluid. So it's really this low compressibility, and you want that low compressibility to stay the same over a wide temperature range. So within the operating range of the brake fluid in the race car, you want that compressibility to stay the same. If it changes, then your pedal changes, and then the driver loses confidence. So we spent a lot of time developing the molecule so it behaved in that way. Obviously, lubricity is a big issue, as I mentioned now, with ABS systems on race cars now, particularly the closed-wheeled systems. So it's something, there is a major racing brake fluid on the market which does suffer problems with lubricity. We became aware of that, and we engineered that into the product because it is a problem at high temperature. So you need to maintain that lubricity at high temperature. And all of those things are, as I mentioned, it's a custom design molecule. So we sat there and we worked out, we got the ingredients and we started reacting things together to make this molecule. And then we played around to get it to perform exactly how we wanted it to, and we took it on with Flying Lizards, Lamborghini team. We did a lot of hours on the track with them, testing how it behaved in different scenarios, high temperature, heat soak, and all those sorts of things, just to make sure we could deliver the best brake fluid on the market. with empirical testing, because that's important. You know, you can sit there, I'm a chemist, I sit in the lab with my pots and pans and develop all these things, but if you don't test it in a car and involve an engineer, because that's what racing's all about, it's an engineering discipline, not a chemistry discipline, and get that translated into a product, and that's what makes it different, is the hours we put into it, because we spent 2.5 years developing the product. So and a lot of that was in the car.
Another question, just curious, for a street car that does many track days, do you recommend staying with the DOT brake fluid or use the racing brake fluid? Any seasonal difference in your answer as well?
It depends what the car is. You know, it's if it's a very high performance car, then you know, we do produce, and there are lots of products on the market which are racing.4, so it's a kind of hybrid between the two. So they are a DOT fluid, but they do have a high boiling point and they have all the attributes of a DOT fluid. But really, Halo P1 is a super high end, you know, it's the pinnacle of motorsport, you know, and to be fair, if you're putting it even in a road supercar, you probably wouldn't see masses of difference. You know, we're talking about milliseconds of difference, you know, in a high end racing series. So you know, that's really what the product's aim for. It's a learning experience for us and a constant ability to develop and drive our market and our products forward, but also to service, you know, the high-end race series like Formula One, NASCAR, and series like that.
Okay.
If I may, Brett,
Is it fair?
in fact, one of the projects on which Dan is working at the moment and should be ready to be launched in the market in Q4 2025 is a GT fluid, which will add the DOT4 certification. That is going to be the perfect product for, let me say, semi-pro racing and track days. Because you can use it on the road because it is certified, it is homologated for the road as well. And if I may, I noticed another question, which is about which amount of brake pressure front and rear in a GT3 car is used in our braking point. Is from 120 to 160 bars. And the effort in kilos that the driver has to make is in the range of 100 kilos.
Okay. Lloyd, did you have something to add? I'm sorry.
Just adding to what Dan and Sergio are saying about the DOT4 aspect, the person's asking the question, please don't use the Halo P1 on the road. It's not for street use. It's not legal. It is a track specific fluid. So just from a legal perspective, you cannot use it on the road.
Mm-hmm. Yeah, and that makes sense, especially with everything that Dan was just talking about as well, for sure. By the way, he had a high-end, a low-end 20-year-old Honda Civic, so stick with the
There
D.
you go.
Yes.
But that's awesome.
Some of those Civics are pretty fast, though, when they're tuned up.
That is a good point. That is a good point. Lloyd, Daniel, Sergio, really can't thank you enough for joining us here today. And really happy you're back. We look forward to being able to do the next one as well, and all of the innovation to come forward that Halo P1 has.
Thank you so much.
Thank you.
Well, thank you very much. Great presentation, and congratulations, Lloyd. What a journey. I remember I was actually you were the opening webinar of last year's season, so it's been almost a year and a half. So
wow.
what an incredible journey, and I've seen you grow the brand across the world, so it's amazing. Very happy to see my good friend Sergio is helping as well, and Sergio and I go back many years. So thank you, gentlemen. Great presentation. Great presentation. This webinar has been recorded. It will be posted later on the Epartrade platform, distributed through our newsletter and social media channel. In the meantime, we pushed Halo's product back on the homepage of Epartrade. So for more information and updates, please visit epartrade.com. Next webinar will be on track safety. So once again, thank you and goodbye.
Bye.
Thank you.
Hey, we want to thank you for watching. Now, be sure to like, subscribe, and click on the bell so you're always up to date with the latest racing technology, industry insights, and exclusive content from Epartrade.
Epartrade is a digital platform that we've created basically to make life easier in the business community of auto racing.
Epartrade, there is no e-commerce. It's literally a connection just like at a trade show. So now, any time of the year, a buyer could reach out to a supplier.
When you see a product that you're interested in, all you need to do is click on request more information, and then from there it is forwarded directly to the buyer or to the supplier.
Epartrade really eliminates having to travel, closing down your shop. Now you have a place to showcase globally your racing product and technology.
Land speed record holder George Poteet's Speed Demon rocketed 481 miles per hour at the Bonneville Salt Flats. You don't go that fast without ARP fasteners.
There is no way that we could go the speed that we've gone, the number of times we've gone, with a lesser quality bolt than ARP supplies to us. And we absolutely wouldn't be where we were today if it weren't for ARP.
When failure is not an option, it's ARP-bolts.com.
We're Performance Plus Global Logistics. Our team of dedicated performance industry and logistics experts get valuable cars and components to the track on time in top condition. We provide expedited logistics solutions for the performance industry using direct routes instead of deferred options, and communicate all necessary information to the appropriate resources to meet regulations and ensure a smooth transit and secure delivery, both domestically and internationally. And we exceed customer expectations by providing best-in-class service with an efficient and cost-effective system in place. Contact us today to book your next shipment.
You work as hard as your truck, and you have no time for downtime. That's why more truck owners trust Blue Def, America's #1 diesel exhaust fluid brand. Each batch is guaranteed pure, so you can avoid costly repairs caused by inferior DEF. Demand America's best for your truck. Blue Def and Blue Def Platinum. Put trust in your truck.
With roots in the Midwest that date back well before the Model T, Fifth Third Bank has a long history of serving the needs of automotive companies. While much has changed over the years, our passion for helping businesses put cars on the road and on the track has not. Today, we are more committed than ever as a member of SEMA, a founding member of PRI, and a sponsor of multiple race teams across several racing series. Where can we take your business? Fifth Third Bank.
Where will you find Ferrea racing components? Circle track, drag racing, and any top race shop. In every form of motorsports competition, our valves and valve train components deliver race-proven design and technology. And we've brought that same performance to our street applications as well. We're backed by 5 decades of experience, an extensive range of off-the-shelf components, and our custom valve department has the fastest turnaround times in the industry. Ferrea Racing Components. Stand with us or race against us.
When it comes to pushing the limits of performance, the pros know there's no room for compromise. At Crower Cams, we don't just engineer camshafts and valve train components, we redefine what power means. Since 1955, Crower Cams has been the name trusted by racers, engine builders, and gearheads around the globe. Whether you're building a street machine, a dragster, or a track car, Crower Cams provides the muscle you need to dominate. And with Crower, victory is within your reach.
At SeaTech, we're on a mission to lead the storage industry through innovative custom-built solutions that meet every challenge head-on. Designed for versatility, whether in a commercial setting or at home, we create high-quality, durable products that stand the test of time. SeaTech, engineering and innovation.